Hey ladies, so today we're starting chapter 9, and so just as a note from here on out, these here are all going to be shorter units, so we're not going to have any more quizzes, so it's really important to know that we're just going to have assignments and tests in these last few chapters, okay? So they'll go by pretty quickly, alright? So looking at our pre-calculus 30 outcome, here we're looking at 30.11, and this one here you guys might recognize, we also did this one in chapter 2, but that one was talking about radical functions. So we're going to be looking at the second part of 30.11 where we're just dealing with rational functions, okay? And some key terms that we're going to find throughout this unit is that we're going to look at what a rational function is and what a point of discontinuity is, okay? So let's jump right into it. So here in section 9.1, we're going to be looking at transformations on rational functions. And if you guys remember from pre-calculus 20, we spent an entire chapter on rational functions. So with this chapter, or this section I suppose, this one we're just going to jump straight into transformations on rational functions. So our first fill in the blank there is rational functions. And rational functions are functions in the form y is equal to some function p of x divided by some function q of x, where p of x and q of x are polynomial expressions. And one important restriction here is that q of x cannot be equal to 0. So if you guys remember, any number there divided by 0, it'll be an undefined value. And if you guys even tried putting in any number divided by 0, you're going to get a syntax error in your calculator. So, and what we've seen up to this point is we've seen that when we have 0, that'll give us an asymptote. But we're also going to look at next section, what will happen. There's another option about what happens when we have 0 in the denominator, but we'll worry about that next section, alright? So when we're graphing rational functions, we're going to graph it just like as if it were a regular function. So what we would do here is that we're going to create this table of values, and then from those values, we're going to plot them onto the graph. So first what we need to do is identify the non-permissible values. And if you guys remember those non-permissible values, that is when we have 0 in our denominator. So what values can't we have? So set those restrictions. Then from there, in the second, or I guess our second point here is write the non-permissible values in the middle row of the table. So just to kind of put that out, so here if we have x and y, say if there's just one undefined value, you're going to put that undefined value, so say it's 0, then you're going to plot some points above it and some points below it, and then work through it that way. That way you're seeing this asymptote, or what we're going to see is a point of discontinuity, and from there you can graph it. So here, the third one here is to enter positive values. Positive values above the non-permissible values, so here would be say 1, 2, or 3, so values that are above your non-permissible value, and also enter negative values. So it'd be say -1, -2, -3. Plot some, or I guess choose some points that are on the other end, or I guess the other side of your non-permissible value. That way you can see both sides of what's happening to that graph. And then from there, this is a little point, so choose small and large values of x to give you a spread of values. And this one you can, it's really important to use kind of more of a spread of values, because if you plot them, if you go with really small values, you're not going to see what's happening with the graph. So, and that's also, we're going to learn kind of how to work with it and how to kind of determine when should we use values like 1, 2, and 3, or when should we be using values with 3, 6, and 9. So we're going to look at some examples of that and kind of see why it's important that we need to have a spread of values, okay? So moving on down below, here, I actually gave you here, this graph here is y is equal to 1 over x. That's this wonderful guy right here. And so what we're going to have is we're going to have some different transformations. So our general form here is that we're going to have y is equal to a divided by x minus h plus k. And if you remember, we're still using those same letters, so that kind of gives us a hint. It's those same parameters. So if you guys remember, what does parameter a do? That is your vertical stretch by a factor of a. And so remember what happens when we have that, when it's negative, you'll have a flip or it'll do a reflection. And then H and K are just translations. So H is a horizontal translation. Remember, horizontal will be either left or right. So the horizontal translation by H units. And the last one, K, is, if you guys remember, that one is your vertical translation. So that one we're moving up or down. And one last point that I want to make about K is K also is going to identify our horizontal asymptote. So what we'd have is, say we'd have our asymptote would be x is equal to k. Alright, so just as a little, reminder there, so what happens, what order do we apply these transformations or these parameters in? So remember, you apply the stretches first. In this case, we only have the one. And then from there, it doesn't matter which one, if you use H or apply K first. Just from there, then you apply your translations. So remember, choose or apply that parameter A first, then you can do H and K. So this is, again, probably, maybe you guys are just like, wow, this is just, I feel like I'm doing, the previous two chapters again. But essentially, it's really all the same thing. You're using the same parameters. We're just looking at different types of functions. So hopefully this is really starting to sink into your head what A, H, and K are. All right. So I just want to do one quick example where we're not going to do anything with it. We're going to put these values or these functions into our graphing calculator. And I just want to show you guys what happens when we apply each parameter. So here we'll start off with y is equal to 1 over x. Then we'll graph y is equal to 2 over x, so we add that a parameter. Then here we have 2 divide that by x plus 2. So here we have a and h. And then we have y is equal to 2, divide that by x plus 2, subtract 2. So here we have a, h, and k. And so notice I chose the same a values and I chose the same h values, just so we can see exactly what is happening with those parameters. So I'm going to open up my graphing calculator. So if you guys want to pause this video, quickly put your values in, and I'm going to do the same as well. Alright, so what you're looking at right now, this is the graph of y is equal to 1 over x. And what I'm going to do is I'm going to overlap this graph, so I'm going to put this on the same graph. Here we have y is equal to 1 over, and sorry, we had our a value there was 2. Divide that by x. So here we have the parameter of a. So if you guys notice here, these are a stretch. So if you look here, maybe let's pull out our table of values. So here we have 1 and 1. And using our second graph, I'll pull out those table values there. This one here is at 1 and 2. So that parameter a there is that vertical stretch. So it affects your y values. So a was 2, so you'd multiply those y values by 2. Looking here, we have 2 and 0.5. And if I can make this go away, I could pull out our other value there. There we have 2 and 1. Alright, so 1.5 times 2. And so you guys see that we have that vertical stretch by factor of a. So now what I'm going to do is we're going to compare this blue graph here. So that's 2 divided by x. And we're going to add in that, then we're going to look at 2 divided by x plus 2. So now we've added in that h parameter. So if you notice here, we went from, here we had, if I could click on that right, there we had 2 and 1. So if you notice that h parameter, because remember it's x minus h, so we moved 2 units to the left, so we went from 2 to 0. If you compare any of the other values, you'll see the exact same thing. So it didn't do any sort of stretches, it just moved it h units to the left or the right, and this one here was -2, so it moves it to the right 2 units. Okay, so now I'm going to leave this red graph here on, and I'm going to change our blue one there to have that parameter of, so we're going to add that parameter of k. All right. So now what we have here is our original point here with that 2 divided by x plus 2. So now what we're going to notice here is that now our y value was shifted 2 units down, so that was k units. So it went 2 units down, so it went from 1 to -1. Okay? So this little exercise here was just to show you, prove that point that these parameters do the exact same thing. So here is just another way to confirm that your parameter A has a vertical stretch, parameter H has a horizontal stretch, and K has that vertical stretch by, that many units. Okay, so I'm going to switch back to the notes now. So actually, since we're getting a little bit closer to our 50-minute mark, so we're actually going to stop and change to video number 2.